All right, so let's get started. My name is Rickard Öberg, and I work for Neotechnology. We do graph databases, but that's not what I'm going to be talking about today. The topic for today is a scalable approach to providing open data. And before I start, I want to talk about two parts of this title. One is the open data, meaning the basic idea is you're an organization, either a company or a government or a municipality. You have data, and you want to share it with other organizations one way or the other. That's what I mean by open data. The other part is scalable, which is in two different ways. One is the technical sense, like if you have hundreds of millions of people wanting to access this open data, how can you have that be possible without it breaking down? That's one part of the scalable. The other scalable is also to be able to start simple and to be able to do this in a more and more complex way, but with the same approach, with the same strategy. So it's also on the development side that you want it to be scalable. So you don't have to do this huge project up front. So let's start with an open data cautionary tale. So I've been talking to a number of companies and government, municipalities. They have a lot of interesting data and they want to expose it for others to use it. And one of the easiest way to do that is that you have your database, you have your own internal users and your internal applications that use the data. And now that you want to sort of put it on the web, the way you do it typically is that you implement a web service or a REST API, some way of accessing that same database, perhaps limited. You don't give access to the whole database. But basically, it's some kind of web interface to your existing data. So let's say you are a company that have done this, and it's working fine. And then one day, your operations guy comes to you and say, "Oh my God, the database is so slow. We have so much requests to it. We can't work. None of our internal applications work, and all our users, everything is at a standstill. What are we going to do? What are we going to do?" And then they do some debugging, and you check the logs, and you see what's happening, and you find out, well, apparently someone wrote a mobile app that uses your services, your data directly, and it became a hit on Facebook or Twitter. It basically went viral and became very, very popular. And to make it even worse, it might be that everyone is using it at the same time. Perhaps it's something you check when you wake up. So in the morning or at lunchtime, everyone is using the same app and is accessing the same data. That goes into your production database, and it impacts everything within your company. So that would be sort of a way that it's the easiest way to do the open data thing, but it has those kind of implications. So the question is, what can we do instead? So this would be the basic situation, that you have your internal database, and you have your internal application, and it's providing business value for you, and you want to somehow share parts of that database with the rest of the world as open data. So the scenario that I described looks something like this, that you keep your database and your internal application intact, and you add some kind of API, a SOAP web service, a REST API, or some other type of way of accessing the data. Typically, there might be a search, for example, a search request, so that external applications can get access to your data directly from your database. And then other developers will be writing apps that are basically using your URL. Like, here's the service, here's the data that you can access, and you have many different apps that are using the same thing, and all of those different apps can have many, many, many users. So this is sort of the common scenario, and this is the problem scenario. Because now, if any one of these apps become really popular, it's going to put a really high stress on the API and on this database. There's some simple ways that you can get around it. One is to use a replicated database. So instead of going directly to your own production database, you have a replicated database that they're accessing instead. That's sort of mitigating the issues. You still have the problem that if you have several of these applications that really uses your API all the time, well, now you are a critical part of someone else's business, basically, which gives a lot of problems. So one is that if your service goes down, someone else might lose money. Maybe not, directly, but indirectly, by people not being able to access the application, and they get, bad credit and those kind of things. Right. So I mean that's the basic problem. That's kind of straightforward. So instead of doing it this way, what are the approaches or strategies that you could use for exposing this data for others? So here's another way to do it. So you have your database and you have your internal application as before, but instead of exposing it directly, what you can do is that you have some kind of process, a data transform that reaches into the database, either all the time or scheduled, more typically, like once every hour, once every day, or something like that. Gets the data that you want to export, and you basically do a data dump in a file that you make available somehow. And that's typically a static file download that someone else can access. Then, for the external databases, for the external applications, they'll have to write a data collector that goes and to this repository of data dumps, and they have to collect the data and transform that data into their own databases. They might be having one database or several databases. They might have relational or graph databases or RDF databases or what have you, really. And then that is what is used to support the external applications. So there's a lot of benefits here, both for you in exposing this information, but also for the ones who are consuming this information. So to begin with, in this case, just in terms of load, if this application becomes really popular, it's up to the owner of this application to make sure that their databases scale. That's the first and most obvious thing. The other thing is that they can have a data model that is specific to the needs of their application. It might be that the API that you had before, sort of, they can get the information they want, but they may have to do several calls to it. But in this case, they can tweak the API to this database so that it's more performant and more useful for the actual applications. Let's see. Yeah, so that's the basic idea, really. And also, of course, that you can have several different databases, sort of serving the same application. That's really it. Now I'm going to talk about doing this for a couple of slides. But this is the basic different way of doing it. So instead of having a direct integration API to your database, you do a data transform of the data that you want to expose. You make that available as a static file. And then you have the other side collect that, put that into their own databases, and expose it through their own custom APIs. So let's look at a few details of how to do this. So the first question is, how do you get the data out of your own application? And of course, there's many standardized ways of doing this. If you're using a relational database for your own internal application, you can use database triggers so that when your application changed, you trigger this data transform that fetches the data and puts it into the static file downloads. That's one way to do it. Another way, if your own application is message-oriented, so it's driven by messages and that's what causes changes in your own database, you can have that be a trigger. So that's sort of the active approach to extracting the data. The other way of doing it is having the data transfer be scheduled. So if you do it every minute or every hour or every day, you go into the database, your own database, and you extract the data. And there's a few different ways of doing it. This is pretty standard, really. One is that you take a snapshot. So you can take basically the entire data set that you're interested in, and you make that available. Of course, that's the simpler way to do it, because the problem is that that snapshot can be quite big. So what you may want to do instead is be a little bit more clever about it and see, okay, what has changed since the last time that I did this transform, and I only extract the changes. Because the idea being that if the user has all of the different data dumps, as long as if they have all of them, then if everything is a change from what the database looked before, if they apply all of them, they will have all the data. It's pretty straightforward. So there's all different ways of extracting data from your database to get it into the static files. So looking at the output, what is it that you may want to put into these files? So again, the simplest way to do it would be to sort of take your own schema, whatever way that you store the data for your internal application, and just put those changes into the static files for download. That would be a simple way to do it. A more interesting way to do it would be to translate that into semantic events that describe the change. Because typically the changes in a relational database or in any database is sort of, it's a projection, it's a consequence of something that has happened in your application. So that might be relevant for your application, but it might not be so understandable for someone outside your company or outside your application even. So if you can describe that in a way that is more semantic, that would be better. That's always a better way to go. Then we come to the download part, like how would the external users download this information? And I would probably suggest that you always use the Atom publishing protocol to do this. How many here have heard about Atom? Right? So Atom is sort of started as a way to describe news links. Like when a website has new articles coming out, there will be an Atom feed that just has a list of links to the new articles, and all of the Google Reader and all the different feed readers that are used for reading news on the internet was based on this. But that protocol is also excellent for doing this kind of static data downloads, because basically you will have your feed, and then you have one entry for each of the static dumps that you need to download. And those files can be anything. So in the news case, that will be a link to an article. But in this case, it can be a link to a CSV file or an XML file or a JSON file or whatever format you want to use. So I would probably always suggest to go with that. Of course, you can have other options, would be to do like JMS or messaging integration, but that's way more complicated, and that sort of gets a too tight coupling between you as a provider and whoever wants to use it. If you use the Atom publishing protocol, you just need a web server, and that's it, basically. So that's the simplest way to do it. When it comes to Atom, there are two ways of providing content. One is the embedded, and one is the link content. And this depends really on how fine-grained your data is. So the embedded version is where you have the XML document, the Atom feed, and then you basically have put the data in that XML file as is. That's one way to do it. That's the embedded case. The other one is where, let's say, each entry is the change in the data for the previous hour or the previous day. So it can be a lot of information. In that case, each entry would just be a link to that file, and that file might be pretty big. So for anyone wanting to get this information, they would look through the feed and see, okay, here's all the links, and we'll follow all the links to get the CSV files or the XML files or whatever, and then process them on their own. So if you just use Atom plain, then the list of links can become very, very long. but Atom has a built-in paging system, so you can say, okay, give me the 100 latest files, and then you can page to previous files. And it's designed in such a way that it's very, very friendly to HTTP proxies. So you can put in an HTTP proxy, and all of a sudden it'll be fast, because if several different users download the same file and it goes through the same proxy that you own, you can scale that to any size, really. So when it comes to data formats, this is probably one of the places where you could talk about having a sort of a scalable developer approach. So I've listed 4 different data formats. There's obviously tons more. And I've listed them sort of in the simpler to more advanced. And so CSV files, meaning comma-separated value files, is the simplest way of transferring data, but it also has a lot of limitations. One of the most obvious limitations with CSV and JSON as well is that you have what you call out-of-band agreements. So the one who is reading the file and the one who is providing the file must have some kind of documentation where they describe for the developer what the different columns are, what they mean, what the types of the columns are, and those kind of things. So that's true for both the CSV file case and also for JSON files. Then when you get into doing XML documents and RDF-XML, then you have more self-describing documents. So when you get the data, if you're using the XML namespaces properly, it should be possible for whoever is getting that data to find out, okay, is this a string? Is this an integer? Is this, for example, if you're using RDF-XML, you could have it reference a known namespace like Dublin Core. So you can say, okay, this is a date. So you know what the format is for dates and those kind of things. So depending on your needs and depending on how much time you have to develop it, you can sort of go through the evolution of making, using more and more semantically interesting formats. And you can, of course, use all formats at the same time. So if we look at an example, so this is an example of an Atom feed. So it's basically an XML document, right? This is taken from the Atom Wikipedia page. So you can go to Atom on Wikipedia, and it's this file, basically. So an Atom feed starts with a feed tag, and then it has some description about the feed itself, like the title and a link to itself. IDs, when it was last updated, and so on. And then basically it's going to have entries. So in this case, there's just one, but there might be 10 or 100 or 1,000. And if it's too many, there's going to be links up here for paging, so getting to the previous page and next page and those kind of things, so that it scales. And then, like in this case, this entry, it just describes what is this entry about. Then to get the actual data, you have to typically follow the link. And that's where you put in your CSV file or your JSON or your XML file with your data in it. And in this way, you can also have many alternative formats. That's perfectly okay. So this one might be linking to an XML file. And then this one is the same data, but using the HTML content type instead. So I kind of like this sort of standardized format for exchanging data dumps like this. It's very convenient, and there's a lot of tools and libraries that are available in many different software languages for reading and dealing and writing Atom feeds. So in terms of operations for actually hosting these kind of services, so like I said, one of the benefits with doing a data dump is that it's static data. It doesn't change. Same thing with the Atom feed. Once you've created the file, if you're using the Atom with paging, the old Atom feeds never change. So that means that you can put an HTTP caching proxy in front of it. So if, for example, it's not enough to just have a web server to serve this, most typically for most people, it's going to be okay to just put up a web server serving these static files, and that's going to be just fine. But if for whatever reason that's not good enough for you, you can always put caching proxies in front of that, because it's just it's all static data. There's nothing complicated about it at all. One question also today is whether to host this yourself or not, right? There are services out there, in particular the Amazon S3, which is very popular for these kind of use cases, where basically you're uploading the files to Amazon S3, and they do all the complicated part with making it scale, make sure that it doesn't get lost, and those kind of things. So you could host both the Atom feed and all the data dumps on Amazon S3. Just pay them to do that, basically. So, and if you do it this way, the users of your open data solution, they're not really relying on you to be sort of available all the time, because the worst thing that could possibly happen is that they don't get data updates from you, but their own databases, their own applications, they can control that. So, for example, if you compare to the direct integration API version, where you have your own database and you just have the external users accessing that, one thing to consider also is that if you have service windows, and typically if you have internal applications, you might say, oh, we have a service window, once a month or once a week on Saturdays where we can do upgrades. Now all of a sudden your service window also becomes the service window of someone else that is using that through the direct integration API. And that might not be really a good idea, even though it seems simple in the beginning, but you have all of these kind of both business and technical issues with that model. That's basically it. So I wanted this to sort of be just a description of the strategy, and then we would have discussions about it. If you have experience with doing this or doing the direct integration API, that would be very, very interesting. And I should say that this entire talk was inspired by a post by Peter Krantz, one of the open data guys in the Swedish government community. So if you want to find the origin of this talk, it's basically available on his website, and he has some more information and some comments from other people in the same space. So I'd recommend that you check that out. That's basically it.
Thank you very much,
Yes,
Rickard.
thank you.
Very nice talk.